So please start, Fredrik.
Okay. Hello, everybody. My name is Fredrik. I will present and impersonate someone from Göteborg because I come from Göteborg. And I will speak about the municipality of Gothenburg today. It's a pleasure to be here. I actually presented a case on Göteborg stad 4 years ago in Malmö in the same event. So 4 years down the road in the trenches, and we're still, digging the data. I usually work at a place called Findwise. We work with data stuff, and I'm extremely nerdy in terms of information management and information in all kinds of ways. So bear with me, and I also usually help out at the university as a researcher and a lecturer in the same topic, so I could continue for the rest of the day, if you will, but I will not. So I have 15 minutes and I will be trying to keep track. So, bear with me. The theme of today is how we can use internal enterprise data with the same kind of thoughts and thinking as we do with linked open data. 8 years ago, they put together this book. It's a pretty good reference, and it's as always reprinted and very expensive to buy, but it's also
louder to the one at the back here.
Okay, can you hear me? Good. So it's called linked enterprise data. This is what I'm going to talk about: how you can actually link your enterprise mess up of lots of legacy systems and things you have inside, and make it linkable and semantically enhanced in different means and ways. And one of the concepts that is very popular within data science and information management is master data. One to rule them all, that everybody hopes that will work. It won't, I can tell you from start, because people are different and have different perspectives to why they do codify their information, and also that's the reason why it will always continuously to fail, but it's a good way to say. So I'll say master data, and I will probably not use it the rest of the day. Anyway, so we were in the project that I've been engaged with for since August. We have tried to use different on existing vocabularies or ontologies, call it what you will, domain models, to define things that are, omnipresent if you are a public organization. And it's not, a difficult thing to do, because there's just a few things that are revolving anything you do if you're a public organization. And it's around people, because it's people attending to do services. And there's organization. There's different ways of organizing the things you do to service the public. Then there's places, which is the reason why a city is a city is a city is a city, but it's just instantiated in different geographical spaces and have different sizes, and by that have kind of differences in that space. But in terms of that, it's pretty much very much the same. And it has also services. It's provisioning of different services. Could be public services, or it could also be services, internal services within the municipality. Municipality, anybody, all of you know what a municipality is, but it's a heterogeneous compound of things. So we have energy companies, we have taking care of schooling and education, you take care of elderly people, you're taking care of the roads. And if you mash up all of these different practices, the energy company doesn't have so much to say about education, and the people taking care of the old people don't have so much to think about the traffic. Well, so there's a lot of, obviously, different practices on how to treat your data and work with your data. So that's where we are. So this is an old picture this is not how it looks like now in Gothenburg, but it's a very nice picture of Gothenburg, and you should go there. It's a nice place to be. So anyway, We've been hearing this all this morning. Well, there's always a problem with polluted data, and in Swedish it's been translated master data to grunddata, so that's why I put this picture, because it's you don't want to have shit in your water because you can't drink it. So you better have decent ways and practices to keep track of your data and keep it clean, because otherwise you will have to end up doing lots of data restructuring, and in the end of the day the data will not be useful either. So my standard things here is that, well, in the middle you have something, I like this one here. Standards. We like them. There are many. They are overlapping and they're continuously changing, as you were mentioning here. But they are also, and that's what the reason why you have all these, interoperable hardware things here. It's you need to buy for yet a new device. You need to buy a whole set of gadgets to things work with the other gadgets. But we like them. But we also need domain models, something that defines what we do, as in just explained. What is the conceptual model of the world? We don't want to boil the water, want to make a model of the whole world, but a very specific narrow domain. And the reason for that is obviously because we want to exchange data and information. And if we can't decide going from inside to this one, we don't know how to exchange data. We have standards defining how you transmit stuff on the internet. We have standards to define what is an invoice. EDE, and we have standards to define what is the ways to structure a medical record, and all of these standards are prerequisites to be able to work with modeling. So hence we need to do modeling. What we did then in this project specifically, we went out and said, well, as I said, there is no such thing that there is only one city, and we are not the only one who have figured that the city is a unique position. So there is a project ongoing in the EU called ISA2, or Interoperability for Public Administration. And it so happens they already have an existing model that defines something that's called organization, that has organizational unit. Whoa, it could be a public organization, that's good. It might have a contact point, which is good. I would like to know where I should drop off my kid when we go to school. If I didn't have a contact point, I didn't know which school he went to. It has hopefully some opening hours, so if I'm going to trash some litter, I want to know if it's open to recycle. It's very good that there might be people attending to do the services, and they have different roles and they are related with entities here. And obviously we have geographical entities, geometries telling you whereabout and in which spatial area this is located. Topping this, we were also speaking about services. Services is kind of the key delivery of a municipality. It delivers lots of services. It delivers other things as well. It doesn't deliver products. It's not that you can go and buy a municipality. Well, maybe you can in some countries, but usually not. Then it's dictatorship, maybe. So you have, obviously, a way to organize and define the services provided. And by using that, we have also used this model. It's not the perfect, and that's one of the key takeaways. I would say that, well, the standards, the models that we reuse, the ontologies we find that are useful, they're not perfect match in all senses. We don't have all the data sets, we don't have all the attributes, we don't have all the fields and things. But this is the the key takeaway with the linked data, because you don't have to have a perfect match on the schema. It has to be good enough so you can interlink the data sets, and that's where you start to decompose the stuff and reuse the data. So this is where we ended up. A little bit fewer relationships, as you can see, but that's basically the whole data model with some fields and attributes. A person has a membership in a organization that has an organizational unit. It is located somewhere, and that location has relationships. So it could be a part of the city or the city itself. It has services. It could be a compound of services, which is services as a package. And that is how far we get in the way we have modeled so far. And I will not go into that one. And we obviously have challenges. And this is called death by laundry. I love this because this is how data actually exposes itself. And you ask my wife, I'm very bad at reading the metadata on the clothes because I sometimes end up putting her clothes in wrong temperature. And these are the lovely machines that the vendors are trying to sell us, because they say, well, any shit can go out and it's going to be beautifully displayed. It's not going to happen because this prevails forever. So don't forget that. This means shit in, shit out, if you wondered. And we will end up here in Shit Creek. Lots of data that doesn't have any linkage, doesn't have any good description or resource description or meta models, and we will not wonder why the services is not good provided. So this is kind of a very simplified version of how the data sits today. The city has nodes. Don't go there, it's going out. Aggresso to keep track of the finance status, and the Personic is the HR system. Then they have IDM system for taking care of who's who and so forth. 250 different systems, and most of them have these 4 data sets. This is in Swedish, so I will not go into that, and just explaining a little bit of the complexity of why things don't fit simply. This is my son's teacher, and this is my son's principal, and the line of command here. What we can see here is that I've just depicted how well the structuring in the different systems look like, which means that in the finance system they have this structure plus this structure partly. In the HR system they have not that one but this one. In yet another system they have this structure, and so it goes on. We have multiple views to see such a simple thing, just saying, how does your organization render itself? Well, actually we have an organization that has 7 hierarchical levels, it has 3 levels. It depends on who is asking the question. When I'm going down here, as you can see, it's also the name problem here. There's 2 cost centers with 2 different cost centers with the same label. Hello, unique identifier. What is that? Problematic. For me, I want to go to the school that doesn't have the org unit because it's not persistently stored in either the finance system or the HR system, because the different practices don't organize their structured data in the same way. So this is what I've been working on for quite a while in those washing machines. So should we just move into the pilot? We've been using terms for keeping track of taxonomies and glossaries and stuff, and we've been using Workbench to keep track of the entities in the relationship. And this is the simple model. Person has, well, I just went through that one. Model. And as you can see here, we have used a sample of reference data. For instance, a way of classifying what is the organization we're talking about. We have a classified data set that's stored and held by Bolagsverket. They understand it's their main purpose to keep track of that one. Here we have a structured glossary with all the different roles and responsibilities one can take. So in the city we have 2,500 terms defining what you're supposed to do in your work. This is the set of entities we have: person, organization, place, and service. And just to make it, this is not an existing, if you wonder, we have no one called Torkel Torktumlare in Göteborg, but it's just to make fun of it. So I'm just making an example of here. Here's a complex person. He's employed by the city. He's also a citizen in the city. He's also a pupil in the city, and he's also a politician. A person can have multiple roles, multiple facets, and multiple employments. And this is what we keep track of. Being able to codify the people like that. Similar, we have done the codification of the different organizations that we're dealing with and the organizational units, as we see here. Here we have the example I just took with the school, saying, well, actually, it has a relationship to an entity above them, which is the parent, but it also has a relationship to its grandparents. So it's kind of interesting correlations. We can actually have multiple links of things, which is the linked data. And the same goes for places or areas. So here's this place where it's situated, and where we using the GIS system in the city to locate in which parts of the city is this located, this specific thing. And by that, we can get a spatial, narrowing down where things sit. And the same goes for, setting up the services. So this is why we do it. We want to be able to access the information in a very, concerted way, and be able to deliver it either asynchronous, just using the integration engine. So a system on the other side say, well, I would like to have a package of people. Send it to me in a nice format in a package, and it will be delivered to you on a daily basis. Either way would be, well, I actually have a question. I would like to see how many principals do we have in this part of the city that have, well, and then you can build up set of queries and query the system. And both of these two means are what we think is why this interoperability thing is in the middle. So alternative one, and I've taken this from Matthias. I'll show you here. So here is a description in Turtle where you see one of the persons we have in the database. He's not actually working at Göteborgs stad. This is Benny Andersson. It's just an example. And we can do the same. And now my time is running out. But anyway, with a similar set of query showing in another RDF format. And we can do the same with the Sparkle query. So, and by the end, obviously, a graph. So this is how actually it's stored in a graph. I dare to say we won't use the graphical visualization of the city to the external facing site, but it's fun to show. So for the future, okay, my hope, and this is the hope for the city as well, is that we will have interoperable, useful domain models that we have reused, the standards that I mentioned, and then be able to publish the way we use those models, so the 290 other municipalities around Sweden could basically use the same models. Obviously they have different values, obviously because they have different names of things, but there are opportunities to have a national way of structuring the information. And end. Questions?
First, it's Paul.
Yep.
I have a bit of a technical question. From one of the screenshots, are you using some kind of UML-like tools when you do the modeling?
Yes.
I recognize the enterprise architecture, I think.
Yes.
So I was interested in that actually because some of these tools which were developed for the semantic web don't seem always that user-friendly. So how does that work?
Well, I would say that enterprise architect takes some craftsmanship to get started. It's a pretty decent tool. The problem was that the city had done multiple modeling. I say multiple. When I started this, I found at least 10 different versions of the same thing in different Visio and what have you, graphical shit, not to be used. So one of the things we did was actually to take those core vocabularies that I showed you and put them into Enterprise Architect and we'll model them into Swedish. So we have now a göteborgsk version of the lovely ISA2 vocabularies. That's the first step. But then we decided, well, if I may go back to the kind of the simplified model here, showing that, well, I mean, since the instantiation of how we actually put things together here, yeah. Well, well, anyway, so.
So does it support natively modeling like semantic web or OWL or something, or is that, do you tag that somehow? Do you use the UML modeling and tag on the semantic part, or how does it
Well, the ambition from my part was first, well, I will put it into the repository in Enterprise Architect because I like UML, because it's a very nicely way of describing your domain. But then I realized it's like you have the opportunity to save it in RDF schema, as the way we express it in Meta Solutions solution. We decided quite frankly that, well, anybody who's tried to use Word and save it as HTML, if you look at that HTML coding that comes out on the back of the scene, it looks like shit, really bad. It's populating lots of stuff you don't want to have. So to make the modeling, I like to have EA or similar tool to keep track of if you want to have different views of the things. But then when I do the instantiation, I don't go the full Monty and actually export it into RDF and make it into the database, because we realize we're going to simplify things you can express very in detail in UML might not be possible to express in RDF schema or in web ontology language. So that's kind of the dependency. In the best of worlds, everything would just move smoothly.
Right. But then your UML model is no longer representative, strictly speaking, of the data in the triple store database.
True. But it's not far off, I would say, because I mean all the stuff we put into an Enterprise Architect are basically the same fields and properties and stuff we have done. So we have not edited so much and made so many changes to the model that I would say that when I left off Enterprise Architect, which was March, well, a year from now, I haven't opened up Enterprise Architect since then. If I did look at the model, it would possibly be a few minor changes, and my ambition is that when we go back and we haven't gone into production, I will just make those minor changes into the repository in Enterprise Architect, which fields and attributes. Because when I did the data mapping, I have obviously there's fields and attributes in the different legacy systems that doesn't have any correspondence to any of the standards, which means we need to define those values by ourselves and say, well, this is a Göteborgsk nice to have field because we need it, because otherwise we are not able to map to that crappy old system, and we need that to save it there. That's the only reason I'd say. More questions? And we're as I said, I mean, we're happy to share. So the ambition will be that when we're getting into production mode and have it up and running, we will also publish it on Göteborgs stads. Nu står det helt still, jag är för trött, jag gick upp klockan 4. GitHub, yes. On GitHub, the documentation, and we also have some ambitions to, well, as I said, several of the things as mentioned here, like the classification schemes, the terminologies, and all the other things, not only the entity diagrams here, are to some extent centrally hold vocabularies. And we have discussions with the rest of Sweden to how to discuss this, because it should not be a responsibility of Göteborgs stad to keep track of how you define services within the municipality, for instance. Any more questions?
I think we have to move on.
Yeah, sorry.
Thank you.
Thank you. Thank you for having me.
Did you change order with Eric?
No? No, maybe no. I thought it was me, but I don't. Okay, Eric, please. All right. Okay. It's a bit confusing. Okay.
Just say that very clearly to the video.
Yes. Good afternoon. I'm trying to get this mic on. We change order, obviously. My name is Olle Bergdahl, and I work as e-governance strategist at the executive office at City of Uppsala. And I'm responsible for the work with the provisioning digital services to citizens and to enterprises in Uppsala. And I'm also responsible for the work with open data in Uppsala. So I'm very pleased to be here today. I think we should start to collect some data from you, and don't be nervous. I'm just a bit curious about how many people are, so this is a poll, how many people are not from Uppsala who traveled here today? Okay. Very good. Because I have just some pictures I want to show you in just 1 second here, if I can get my PowerPoint working correctly.
Your screen is not sharing.
Yeah, I know.
Still HDMI, right?
Yeah, it's exactly. I think it's always interesting. It's like 2018, and it's still a little bit of a hack to get this working properly. So I'm very glad that we could have this conference or symposium in Uppsala. And just in the case there were not many people living here, I will just show you some picture of what's going on in Uppsala. We are the fourth largest city in Sweden, and one of the fastest growing cities. Within the next 30 years, we will grow 60%. So we're building like 3,500 homes every year. And this is Juvela, one of the signature buildings near the train station that is being built right now. One of the Swedish biggest construction development projects is Ulleråker, and it's located nearby between the two universities, Uppsala University and the Swedish Agriculture University. And in this project we plan to build 7,000 new residential homes. And we have also taken I think a quite an interesting approach in this project, because we will add innovative solutions, IoT, data within the fields of mobility, energy usage, and things that can provide better life quality for the inhabitants in Ulleråker and Uppsala. So we're not building streets, we are not building districts, but new city areas in Uppsala. And it's a bit of a challenge to do that in working with sustainable development, and do that in a way that we can include the people in the process. And I think data can provide some solutions to be more transparent and to be more inclusive in the development. Smart cities is on the agenda and topic for all cities, and this is the way that we in Uppsala believe. It's not just about technology, it's about the people. So we take the people approach and the holistic approach towards smart cities, and we think that it should be people focused. What we have done in our city governance model is that we have implemented or been influenced by the global goals. So we have implemented this in our steering document that is decided in the political committee decided by the city council. We have also organized the organization, so we have the Department of Social and Ecological and Economic Sustainable departments are in the same office, and that provides a holistic approach to sustainable urban development, and I think that's really important. So what we have done in matter of being more transparent to the citizens in Uppsala, I should give you just some example before I go into open data more specifically. Last year we launched a new digital services with the goal to increase better public understanding of municipal budget and goals. Before you can read like a PDF document on the website, like one updated once a year in the end of the year about the results and the budget and goals and such. Now you can follow on our external webpage a digital services that, I mean, it's updated every week or month, the budget, but also our decided goals. Are there any deviations, or are we on track with the goals and such? We are completely transparent with everything, and if there are something, it's like a traffic light sign kind of approach. It could be green, yellow, or red. And if there are any deviations, we are completely transparent of what is going wrong and what are the plan to fulfill the goals. And the response from the public has been very good, and we aim to develop this further. And of course, open data and linked data could be one thing to making these services even better. About policy and commitment, I think this is really important, that, and it has helped me a lot in my work with open data in Uppsala. In October 2015, the City Council decided a new IT policy, and it stated some things within this policy. That open data should stimulate innovation and facilitate transparency. And transparency, part of it is really important. And the political board really believes that working with digitalization is not only providing better services, but even, I mean, develop democracy and be more transparent. So that is one of the things we target specifically in our plans. You can say open by default is also like one thing that is mentioned in this policy, and it provides us. I mean, the data should be. It's not our data, as in the city. It's the public data. It should be open by default, of course. Also, we have one document that was decided by the municipal executive board, and it's a guideline for open data, and basically it's the principle of open government data. Unfortunately, back after 2014, the license model chosen was Creative Commons by, and we will do a license update on that to be even more public, you can say. We will go for Creative Commons 0 instead. That is similar to public domain. And here you can see some of the current work in our roadmap. We are very proud of being one of the first municipalities in Sweden to publish the entire primary map. And that is, I don't know how many people of you here are familiar to geographical information systems and such, but the primary map, or baskartan in Swedish, is the most complete resource around the city data and the city map, and it consists of 42 map layer in the geographical information systems. And it's launched as the Open Geodata, street names, buildings, roads, etc., everything within in the license Creative Commons by. And you could say before we had the strategy to wait and see what happened, and when we evaluating that, guess what, it didn't work. So now instead we're doing things, and this is what made this possible was actually that we had this IT policy decided by the city council. It should be open by default. And that helped me a lot in the arguing with the information owners in my organization, convincing them that I believe in democracy, and this is not our data, it's the public domain. We should open it and try, really not wait, but rather doing it. And this was launched in our old geographical information system platform. So now we're working on updating that to enhance services, even more formats. A new license model will be updated, as I mentioned. And we have also stated in our open data roadmap that we should publish open data as linked open data as well. I'm looking forward to that. But also dealing with real-time data from IoT implementations. And that is a bit challenging around storage, around standards, what to store and not, and how to aggregating the data, how to making that available. So we are dealing a lot with that, and we're working closely with some 140 other cities within the network of Eurocities. So I will be in Belgium next week discussing in different work groups how we can targeting specifically the real-time open data issues. Possibility and challenges then. Our organization and competence within our organization are more tailored to managing system rather than information. We have a tradition to deal with technology rather than information, and that is a huge challenge. Now we're shifting from in the procurement process and the cloud delivery models as well, allowing us to focus more into information and data and managing that rather than managing updating of the systems. But it's a shift in both organization and in competence to be ready by doing that. We also do have, I think, Gothenburg, you mentioned some 250 systems. I think we have, depending on how you count it, I think we have around like 300 systems in Uppsala, and most of the systems are delivered as vertically integrated systems. So they are basically silos, not interchanging. They are not interconnected. They are not changing data whatsoever. So that is a big problem, and also the lack of. It could be, they are on old technology platforms. They might not have the possibility to with interoperability and such. I'm not talking about just the technical thing about it, rather than legal, organizational, semantic, and all aspects of interoperability, but also, of course, the technical. It's really difficult to harvest the data from legacy systems. And in the procurement processes nowadays, we demand systems to have open APIs and a more standardized way to interact. And that's one way to develop this forth, but we have to deal with the legacy systems as well. So, definitely. And the culture, that is definitely one thing that is challenging. Information owners might not see the value, and it's also a paradox maybe. The value the work might exist in one part of the organization, but the value might be created outside the organization or even in some other place. So it's some sort of paradox, so to speak. Why should I, as a information owner, concerned about this? I am not maybe the one who taking the good result or the one earning on it, so to speak. So it's a really difficult thing to deal with the culture. And I do believe that leading by example, be very, very specific about the use case and talk rather about value than the technical thing might help by doing that. I see that we have some initiatives that are driving this forth. Digital archive projects are within all municipalities in Sweden, I would say. And naturally, you have to deal with information management within those projects, and it's about, I mean, knowing what you have already, structure the data, and the system part of it. And I think if we can be very smart in having those projects and connect the open data and linked data approach to it when we're already doing the work, we can be more beneficial by doing so. Citizen participation and service design are also initiatives that are very correlated, I see, concerning dealing with this data and the open data before, and all together is making this culture. So I don't think there are like one single strategy or silver bullet idea of succeeding in this, but I think the right approach is not to wait, just doing things, and be very good to package the result in a way that you can communicate around it. I also think it's very good to use like research and development projects as a great possibility to include the work with open data and linked open data. And I give you two examples of Internet of Things related projects. We have Green IoT here in Uppsala, and it's about a platform project, you can say. It's about the evaluation of information-centric networking. And we use air quality as one use case to manifest the results we are doing. And also together with Göteborgs stad, LOV-IoT, which is about air and water monitoring. And Björn Hagström, who is here today, is within this project as well. And here is just to give you some, here's what it can look like when we are mounting sensors in the streets, measuring air quality with budget and semi-professional sensors. And here we are interested in PM 2.5 and PM 10, of course, in this project. And therefore, I also have some candidates for linked open data, air quality monitoring, or food control data would be interesting. And maybe we might can discuss that in the coffee break, if you have any other ideas that could be interesting. We have done a digital services around the food control data. We are very proud of these services, and I think the benefit of this can be even greater, of course, if we can publish it as linked open data, so it can be implemented and the data can be used even more. I mean, collecting the data and using the data for better decision making in the organization is good. Making it available as open data is, it's fairly good, but the value will occur when the data is used. So we want the data to be findable and searchable and usable. So that is why we are interested specifically in the food control data to be published as open linked data. We have some collaboration agreements. We think that partnerships are very important, and we do have a collaboration agreement with Uppsala University. And I think this model can be developed even more. I think it's very successful. What happens in the city when we bring a challenge and we bring the data to the room and collaborate with very skillful students working in different projects to develop the next generation services around that data to target a specific challenge we do have. So, and we have done that in one project around bicycling. making this, what can you say, bicycle app that can be used with different for different things. I think it's pretty interesting, and we can develop this concept even further. But we need a way to package the data in such that it can be usable, and I think linked open data is one solution to that. So if you're interested to reach out and connect, you are more than welcome to do that. You will also have the presentation. I will send it so you will find it on the web as well. So thank you.
We're a bit behind schedule, but we have a lot of time for discussions and fika, so maybe one question.
You have a collaboration with Gothenburg.
Collaboration in Gothenburg, yeah.
That's what Fredrik was talking about.
Not that project specifically, but we are within a research and development project. But we are, Fredrik's presentation is of course very, very interesting and very relevant in the work we are doing. So please, we can continue the discussion.
I can say, but the only thing is, the reason why we chose a open platform was that we have similar things ongoing with open data and BSI directive from the Gothenburg municipality perspective, and that means that we want to change the data. So the data that is internally seen as master data will become public data as well. So it's reusable across from internal, codifying codifying to external facing services, whatever that could be.
Yeah, and I said it so many times, but I think it's worth to repeating that we in Sweden is a very small country, and we cannot afford to avoid collaboration. But not only talking about to collaborate, but rather doing several projects together. And I think one key to success is to find partners, different cities with the ongoing initiatives, and work together transparently and open for a better public good. Yeah. Yeah.
Thank you.
Yeah. Thank you. Yeah.
Do you hear me? If I try to speak up quite loud and clear, will I do without this? For the coming generations.
Is it also
Yes.
Had a connector.
There we go. In some sense like this. Let me see if I have a screen here. There we go. Lovely. 15 minutes. That was what the time we had. I don't know if anyone else of you have noticed, when you connect any Macintosh to any system, there's at least 10 seconds delay before it goes into the image. I don't know if there's some sort of conspiration against Apple users. Erik Wallin is my name. I'm working with buildings. I'm trying to make buildings smart. Did something happen?
Is the cable a little bit?
It's back. I'm building smart building platforms, and I'm using ontologies for that. I have done together with Vasakronan. Vasakronan is one of the, or actually the largest commercial property owner in Sweden and in the Nordics. And together with Vasakronan, me and my small company Klipsk has started to develop a platform for collecting all the data. And then you very fast you run into the problems of all the kind of different data that you have in a building. Klipsk, we are building machine learning applications. What we're using all this data, all this ontology-enabled data to make a knowledge graph for buildings. And what I will talk about today is something we call real estate core. And real estate core is something that has been developing for a couple of years, and it has actually taken quite a big speed in the end of 2017 and the beginning of this year. And the real estate core is actually what's important for real estate core is that this is an ontology for property owners. And it's also made by property owners. I mean, when you talk about smart cities, smart buildings and everything, it depends on who you're asking what kind of answers you will get. So we are extremely focused on actually solving the problems for a property owner, not for a supplier of this kind of screens or for ventilation systems or for any other system into building or for managing the building. It's for the ones that actually own the property. We are doing this as a joint effort, as a consortium with Akademiska Hus and Vasakronan and Wilhelm, as three different types of property owners. And we are doing this together also with Jönköping University, with Carl Hammar down in the corner there. That is the expert ontologist toolist. I don't know if that is a new title, or a new profession. Chief ontologist I have seen in a couple that someone has in their description of the titles, but chief ontologist toolist I think is still to come. So what is real estate core? Real estate core is focused on three different areas. For you familiar in the building sector, you have a concept called BIM, Building Information Model or Management. It's a very wide concept, and there is being heavily invested into this. I mean, you from the councils in the cities are probably using this. And that is basically the digital representation of a building. But BIM is extremely focused on the actual building or the roads or whatever hardware you have, and it's extremely focused on actually planning how to build a house. It's not so it's not so focused on actually operating the building. It takes a couple of years to plan and build a building, then it should live for 100 years or a couple of 100 years, and that is a part that BIM is that's their soft spot. The other very important part from a property owner is the control of a building. The climate, the access control, the lighting, for example. And you have several different standards and you have several different vendors within this area. And then just to complicate things for everyone is all the new things that are happening within the IoT arena. All the new standards, all the new kind of disruptive technologies, disruptive ways of working. So what real estate core is, what this ontology is actually trying to take these three domains into account and making an ontology that we can use for our smart building platform, where we're collecting all the data from the building and what's happening within the building. Why do we need this? I think I would actually say, you probably heard this before, but I will just repeat it because I think it's extremely important to separate from different pilot or proof of concepts that we see everywhere in the time. I think we heard before about different silos of data. Because that is what I think we see now when we're looking at lots of different smart buildings and smart city or smart grid society, whatever you put after smart, is the problem that it doesn't scale. If you are going to, Vasakronan has 2.5 million square meters in properties. Together with Wilhelm and Akademiska Hus, it's almost 8 million square meters and more than almost 1,000 buildings. And if you're going to do this in the Vasakronan portfolio, when we're just looking for climate control, we are looking at circa 0.4 data points per square meter. So we have just 1 million sensors out there, or data point sensors, in Vasakronan's portfolio right now. And that is just legacy sensors. And then we're just sprinkling it with new IoT sensors everywhere. So it's a huge amount of data to handle. And then, of course, as I see this is the start of the smart city, of the interaction. As the property owner, we really need to get control. We need an interface towards the smart city. And now I'm jumping over to what I think is much more fun for the audience here, when you actually start to looking at the real estate core. This is the real estate core 2.1. We have in production right now the 2.0. The 2.1 is being developed together with Carl Hammar, and it actually it basically has three different domains. It has the core domain, the domain that keeps tracks, where we actually keep the definitions of how do we describe location in a building, inside, outside, and how do we actually interact with other geographical information systems. How do we map this? How do we map this with the city so we can actually place it? Time, I mean, sounds silly, but I don't know how many different time formats you can find from all your systems. How many systems didn't you have? More than 300-400? Yeah, how many different time formats do you have? A few, yeah. And measurements units, of course. So in the core part of the taxonomy, we're just trying to gather all these. And what we're doing when we're doing this real estate core, we're actually mapping. We're really not trying to invent new terms for temperature or for that, but we're just trying to find the least common denominator for a term, and then we decide that we should call it temperature, not temp, not temperature, not T or whatever. It's called temperature wherever we're using that. Building structure, that is the next challenge that we really need to have a clear view over how we see the building. Both in the components that builds up that makes up the building, and also from the administrative perspective. And then we have I would say the more new part of it, the IoT, or of course we have old devices and old sensors as well, but how we describe this. And this is an example of our extremely pragmatic perspective, that we're actually putting things into production. These are the most these are the minimum viable components that we need in order to have an ontology that works. I will show you later on how we were going to develop it. So the real estate core 2.1 is actually of a modular design. And as I said, we right now have in place the building device and the core. We are working on energy, access control, productivity, GDPR. These are just a few that are very, very close in time that we really need to have in place. I don't know how many of you live under the threat of the GDPR of the 25th of May of this year. I guess a few of you, a little bit. Everyone is sleeping fine, but you're not responsible for it. It's not your responsibility. Lovely. No one is a data controller, has that on their, didn't get that title in your latest review, work review. Good. Because then you can actually get you can actually get prison, I think, if you're a data controller. Let's see we'll see when they will strike down when we're trying to set some examples. will be XVCC. But the thing with this is that it must be very easy to customize and actually to reuse the ontologies. And I don't know if you're familiar with the design pattern when you're designing ontologies. That is, of course, something that we're looking on as a way of actually composing the ontologies. And also control vocabularies. I mean, an ontology without a set of controlled vocabularies, for example, this when we talked about temperature and we are talking about units, SI units, for example, are very, very much needed in order to actually make it work, to make this mechanism for a language to work. And we are putting very much effort into mapping to other standards. As soon as we integrate to a new system that has another standard, then we're just making a mapping and we're supporting this in the ontology as an annotation to a class or to an individual. I should speed on a little bit. I said it was three dimensions that we're using right now, and that are the most. We really need to have those in place in order to have the system to work. It was the core, where we have the location, and for an example, we're using two properties: is located at, is located in. Is located at is a fixed position, a VGS 84 position. Is located in, then it's in something else, a room, a building, a facade, or a space, or whatever. Time, and I didn't put all the classes or properties here, but just an examples. So we are just agreeing upon that we have start time, stop time, duration time, etc. Measurement units, as we said before, also that we agree upon what we are calling the different measurement units. And of course we try to comply with already known standards such as the SI standards as much as possible. The building structure, I mean, we haven't invented this, on the contrary, but we have real estate, you have land, you have building structure, and then you have the building structure components, room, facade, roof, etc. You have administrative definitions or classes such as storage level and premises. For a property owners, the knowledge of a premises, I mean a collection of room and spaces that you actually have a contract, is extremely important to understand if you rent it or not. And you can calculate KPIs based on different premises types, etc. And then the last one, devices. We're using an SSN standard model with a device that has one or more sensors and actuators. We are working extremely much with legacy systems, so we have a class that's called device communication. What kind of communication are we using, and how are we configuring those? So we can actually describe that in the ontology, which means that we can do reasoning, we can do some sort of reasoning and some sort of higher level of automation due to that. Observation, quantity and kind, and placement type. If I may brag a little bit, I would say that the things that I think that we actually contribute that hasn't already been done before, I think we're basically just collecting all the standards. We're just trying to make them from a building owning's perspective, how we are sorting the standards in the different classes and names. But the quantity, kind, and placement type is that we are actually breaking down, that we're talking about. We have a sensor, and then we see, what is this actually measuring? Is it measuring temperature, flow, CO2, TVOC, PM10? What is it actually measuring? And then the placement type, where is it placed? If it's a temperature, on a radiator or on a cooling baffle somewhere, if we have that here. Oh, I couldn't see one. Probably could be one of those. If it's a cooling baffle, is it on the primary flow in or on the primary flow out? So in this sense, we have actually found a few sets. And of course, we haven't totally invented this, but I think we have actually used lots of other. We've been standing on others' work and actually making this into an ontology, which makes it for us extremely helpful when we are going to do some sort of machine learning or reasoning at a later stage. That we can understand that this temperature, was it actually an in temperature or an out temperature? Last slide. The tools we are using right now is Protégé, Vidocco, and GitHub. So we are doing the building the ontology in Protégé. We are doing the documentation in Vidocco, and we are handling the versioning and lots of the presentation, the publishing of the ontology in GitHub. On the roadmap right now, what we're working on right now is access control and energy, GDPR. How we should expose this as JSON LD, because when we're looking at how we are using this ontology, we are not using any triple stores. We are using plain JSON files, and we are probably going to move over to use it in production in JSON LD. But this is just one thing, that how do we actually put this into production? That is one thing that we are working quite much on. And this will be published in the end of May. So then we will make this official. If someone is interested, we are going to release this to a few of the ones that we're working on. We're working very close with Microsoft, with their smart spaces that they are actually launching any day now. We will have a presentation tomorrow together with them. And also we are working quite close with Ericsson and with Schneider Electric on developing these things for building owners, for property owners. Okay, I think I'll probably used up my time there.
17?
Hmm? Hmm?
Go ahead.
So it's interesting to see. We have another project with Naturvårdsverket where we are looking at recording measures of various sensors.
Yeah.
Or actually, we are not doing it, but we have it with the linked data representation. And so doing that work, we stumble upon the data cube. I don't know, have you seen the data cube? It's a V3C recommendation for storing data.
Where you get stars.
Sorry?
Is that this where you get stars, the data cube? No? No, sorry, no, I haven't seen it then. Terribly sorry.
It's very, because they have observations and they have like measures, attributes, and dimensions, and there is a way to tell the unit that we're measuring, and so there is some overlap. I think maybe it could be interesting to, if not use, maybe get inspiration.
Yeah, definitely. No, the purpose of this is that since we are actually, when you see this in the modular perspective, when you see it as, we would like to have an upper ontology. So we actually can starting to connect other things, and we can start to interact with the smart city. I mean, to get data from the city, from all other thousands of different vendors of data or producers of data. And I mean, I've been working quite much with SSN and SOSA, which are ontologies for sensors, and I have a hard time to get them actually to put them into production, to actually get them to work. To me, it feels like, especially when you're working with actuators. I mean, when you actually, not the sensors. Sensors are much simpler because they have an observation or not. When you have an actuator, you should actually have an actuation, and you have several different properties, and you have lots of other problems to work with there. But I will check that out. I didn't see that.
Follow-up question. Are you modeling like the units and everything as Gauss vocabularies or something, or is it like classes, instances, and in ontology?
Now it's classes and instances.
I was just curious, since you were building on, like the modeling for BIM.
Yep.
All the concepts, related to a building.
Yep.
Did you have, control vocabularies or standards that you could incorporate kind of into a terminology, so you actually define your things using those terminologies? We are mapping to IFC, which is the native format of BIM. A little bit reckless, you could probably call it like that. Then you have several different standards. I mean, there is no lack of standards, and when it comes to, if you're looking here in the Nordics, you have BIP.
the building information properties classes that you usually use when you're designing a building now. When you get a new building, you get BIP codes for everything. So we are actually doing that as annotation properties, which means that we can use as mapping. We don't use it. We don't apply a reasoner, but we can later apply some mechanics, some script or some function that can actually later translate. So when we get data from when we have a BIM model of a building, then when we get data from that BIM model, we get the sensor has a BIP code, and then we can just it was temperature because it was BIP code, whatever the number was. So we are in that sense we are mapping to, legacy standards and old standards, and it's extremely simple to, if you want to add another standard, such as Vasakronan has internal standard, or actually not just one, they have several different internal standards. And when you took it, so it's a way just to handle proprietary standards and whatever standards you run into.
I wanted to ask, there's very, very interesting robotics projects where they're working on programming semi-autonomous drones to work on construction sites. And I'm wondering if, looking forward, you see a possible integration with what you're developing.
Well, again, since this is there's a lot of things going on in construction, but since this is an ontology for property owner, you should actually, of course, you do buildings, so you do remodeling and you do refab. You're rebuilding your buildings all the time, but in that sense, since we have a location model that we're using, if you're using that for drones, right now we're doing quite much 3D scanning. The problem with BIM models are that the problem with any architectural drawing is that if you compare a drawing of this building, I bet you that if you have more than 95% accuracy between what actually was built and the drawings, then it's quite good. So that is a huge problem that you have. So right now we're using scanners, specialized scanners that can scan a building, a complete building like this in maybe a day or two, and then we get, and then they have a special software, these companies, that they can actually transfer this into some sort of a point scanned image that you can actually map on a BIM model, and then you can see how much it differs and where things are not right.
How did that location system work? Like, if you could pinpoint a geographical position in a building, like not really accurate, not as GPS, or just like on the decimeter scale, perhaps.
Yeah, or actually, when it comes to location, we have this class called location, which actually holds an exact position in VGS 84. But since we're pragmatic, when we go into a building and get all the data out from the building, we have precise location for lots of sensors in the blueprint, in the drawing at least. Yeah, of course, if 9 out of 10 are right, that's much better than nothing. So, but then we see that we are also having an object. Of course, when we go into specific, that we have a local location, that we have a local coordinates. So then we can use a local coordinate system, and then we just have support for doing a coordinate transform, because that's how we actually have to do it when you do it in buildings. So then you can have a local coordinate system. You have to. We are quite pragmatic. But then you see with IoTs and with indoor positioning now there are promises with this decimeter positioning indoors coming up, and when we start having that, we will hopefully have devices that will position themselves, and we will get that data from them. But again, if you're looking at for Vasakronan, which is a leading property owner and that are building extremely much new properties, if they have, I don't know, 1%, no one actually knows of all their buildings are in the BIM format. The rest is in different, all down to paper and up to some other CAD formats. So it's really, when you're building new, then it's no problem. But on the buildings that you already have, and the buildings we have in our society, and everything we have in the city, you will not get that kind of precision. Okay. Thank you.
So I think it's we are a little bit late. It's not catastrophic. So we're supposed, according to the agenda now, to divide into groups and discuss things. That means that you need to be engaged.